All right, folks, I'm back, and with a different shirt. It's Mr. Wen here, and I'm here to help you with the circles playlist in the Math 2, specifically for those in Algebra 2 right now, or in 10th grade. So, uh, to begin, right, circles, it's kind of tough when you just kind of look at it, but when you really get into it and start to understand the proportions specifically, and memorize some of the formulas, it it's pretty easy. Just you just gotta take your time for this one. So we're just gonna jump in real quick. The first 4 or 5 questions actually is almost purely definitions, and so we're gonna go over the first half right now of key terms that we need to know in order to pass those 4 or 5 questions. And then we're going to go over the second half of the key terms, in which I advise that you take notes and write these down, because these are things that will be on the playlist, on the content assessment. So first and foremost, we're going to go over the basics of circles. And the very first 4 things I want to go over is radius, diameter, circumference, and area. Okay? This should be reviewed. But for those that isn't review, we'll go over it just to re-jog your memory. Okay? Radius is simply the distance from the center of a circle to the edge. Okay? If I were to draw a circle, I'm going to draw it right over here. Okay? It's not a bad circle. Okay? If the very middle of the circle is right there, okay? From the middle to this edge, right here, touching the edge, not going any further than that, that is the radius, okay? All it is, again, distance from the center to the edge. That's the radius, that's the radius, that's the radius, okay? Nice. Next thing we're gonna go after is the diameter, okay? The textbook definition of diameter is the distance across the circle through the middle. Okay, that's really important that it goes through the middle, because if it doesn't go through the middle, then we're using a different term. But we'll talk about that afterwards. Okay, the distance across the circle through the middle. Think of it as if you had a pizza and you folded it directly in half. That crease that you created when you folded that pizza in half is what the diameter is. Okay. So if I were to draw this on this circle, right? Okay. And to prove a point, I'm going to keep the first radius I drew there. Okay. Diameter is going to be from the middle to the edge to the other edge in one straight line segment. Okay. If you notice, okay, it's just 2 radii, the plural for radius. And so diameter, okay, quality is 2r will always equal diameter. Okay, that's cut and dry. 2r will always equal diameter, same as diameter over 2 will always equal radius, right? Just the algebra, create a formula for it. Awesome. Cool. The next thing we need to know, and I emphasize that we need to know this, is the circumference of the circle. And the circumference, the textbook definition, is the distance of the perimeter of the circle. Okay? Think of it as the entire pizza crust. When you order a pizza, large one, a medium one, a pan one, a personal one, it doesn't matter. The crust is going to be the distance of the perimeter of the circle, aka the circumference. Okay? If I were to point it out on this circle, it's this, right here. Right there. Okay? The important part, well, conceptually you need to know it, but the other important part is the formula for it is going to be C, okay? C, meaning circumference, is equal to 2 times r, which means radius, times pi, okay? Or, in other words, circumference is equal to diameter times pi, okay? Circumference is equal to diameter times pi, okay? These are exactly the same because remember, we have a 2r here, and 2r just means diameter, okay? Don't get that twisted. It doesn't matter which one you It doesn't matter which one you memorize, as long as you memorize one of them. Okay. The next thing we'll go over is area, and specifically area of a circle. And the textbook definition is the number of squared units inside of an enclosed shape. Okay, that's kind of boring. Think of everything that you can fill in a two-dimensional circle. Okay, and going back to the pizza analogy, it would be everything on the pizza. Okay, it's squared units, which kind of throws the analogy off, but whatever. The important part is that you memorize that area. The formula for the area of circle is pi r squared. Pi r squared. Okay? Say it again. Pi r squared. Okay? That's going to be the first half of key terms. And it's really important because we're going to use these formulas in trying to find out sector arc, or arc length, and sector area in the next few minutes. Okay? So the next set of key terms that we need to know, and this is all of them except one, in which I'm going to talk about right after we go over these. The first one is called arc length. Okay? It's the textbook definition: portion of a circle's total circumference. Okay? The key word there is portion and total. If I were to show you on a circle, okay, this circle right here, it's a little small, but work with me, is that if I took this pizza, we're going to go with this pizza analogy again, and if I cut it in a slice, this piece, right, this piece of crust, just this piece in which I'm eating myself, is what is going to be called the arc length. Okay? The problems on the playlist, they're going to ask you, how long is that arc length? The next thing we go is sector of circles. Okay? If it isn't apparent, I advise that you write these definitions down in order to get them in your head. It's going to be the portion of a circle's total area. Okay? Keywords again are going to be portion, total. If we go back to this pizza picture, it's not going to be the crust this time, but it's rather going to be the whole area of this pizza. So if this was a medium pizza, and the area was, let's just make up a number and say 24 inches squared, then we're asking for the portion that is just this slice. The next term we're going to go over is secant line. Okay? A secant line is a line on a plane that intersects a circle exactly twice. Keywords: exactly twice. If I erase this circle and I try to demonstrate this right here, there's the circle, and a line goes on continuously, remember. And if it passes through the circle exactly twice, right here and right here, then that is a secant line. Exactly twice, remember that. On the other side of secant lines, we have tangent lines. And these are going to be particularly important for those that are, for actually everybody that's going to go into calculus when they hit 12th grade, or potentially stats. Then it's not as important, but it's still cool to know. Is a tangent line is a line on a plane that intersects at exactly 1 point of a circle. Notice that secant line was 2 points. Tangent line is on a plane with only 1 point. So if I were to draw it onto this circle, okay, that line going continuously in both directions is going to touch that circle just once on that plane, right there. Just there. Just and only there will it touch, and therefore it's going to be a tangent line. Okay? There's going to be questions like this on the assessment, and they might draw 2 or more circles and draw lines across and ask you which ones are secant lines and which ones are tangent lines. Use this knowledge and deduce for yourselves which one crossed twice or which ones crossed once. The last key term we want to go over before we start getting into the actual math of solving for for arc lengths and sector areas is chord, okay, or chords. And this one is definitely, I can almost guarantee you, going to be something they're going to ask you on the assessment. A chord is a segment that starts at one edge in a circle and stops at another edge in the circle. Keywords are in the circle. So, with this circle right here, I'm going to draw a few line segments, and we're going to go over which ones are chords and which ones aren't. Awesome. Okay, and I'm going to denote this A, B, C, D, E. Okay, a little crazy here, but it proves it helps support my point. Okay, so remember, it starts from one edge of the circle, it stops at the other. So A to D, see, it starts here, but it doesn't end at the edge of the circle. It stops right in the middle. So therefore, it's not a chord. But what is a chord is from A to B, because it starts here at one edge, it stops at the other edge. Okay. Same with B to C, one edge to one edge. Is D to E a chord? No, we have that problem again where it doesn't stop or start at one edge. So, little fun fact, that means all diameters are technically chords because they go from one side to the other. All chords are diameters, not all diameters. All diameters are chords, not all chords are diameters. Okay, so we're going to jump into solving for arc lengths with the information we learned not too long ago. Okay, so when we're actually solving for these, and we're going to start with degrees because conceptually it's easier to learn it with degrees, and then when you jump into radians, it starts to make more sense quickly. Okay, so right here I drew a circle, and I'm given this sector. And the degrees of this sector right here is 90 degrees, okay? And the radius, the distance from the middle to the edge, is given to me, and it's 18 inches, okay? The unit of measurement doesn't matter as long as you get the math right. Then you just plug it in later. So what we're gonna do to start out is that first and foremost, we're gonna find the total circumference of this circle, okay? Remember, the arc length is a portion of the total, so we want to find the total first in order to turn it into a proportion and find the missing variable. That was a lot to say right there, but it'll make sense once we start doing it. So first and foremost, let's write our equation. When in doubt, write the formula in order for you to make sure that you know it. Circumference is equal to diameter times pi. It's okay if you memorize this 2 pi r. So the diameter, right, is going to be twice as much as this. And 18 times 2 is going to be 36 times pi. 36 times pi, if I do this on a calculator, 36 times 3.14, this is going to equal 113.04. Okay, this right here is our total circumference. Okay, so we're going to write it out, 113.04 over 1. Okay, it's the same exact thing. We're just going to make it a little easier for when we actually find the ratio in which we want to find the proportion. Okay, so the next thing is we want to times this by the ratio, by the proportion of what this represents of the whole. Okay, so fun fact is that all we need to do is take the degrees of this sector, right? Put it on the numerator over the total degrees, which is going to be 360. Okay? Every circle, the degrees of a circle is always 360. And we simplify that, right? That's just going to be 1/4. So it's going to be 1/4. Okay. If we took out the zeros, 9 divided by 9 is 1. 36 divided by 9 equals 4, equals 1/4. And so we're going to multiply this straight across, right? We're going to do 113.4 straight across to 1. So that's going to equal 113.04. Straight across, 1 times 4, 4. Now we have 113.04 divided by 4. We're going to punch that into a calculator. Divided by 4. And if you beat me to it, okay, the answer should be 28.26. And the unit that's used for measuring right here is inches. So now we figured it out. This arc length right here, okay, this arc length is equal to 28.26 inches. That's it. You find the total, you find the ratio of how big that sector is, times it, solve for it, there you have it. Alright, so we're going to jump ahead a little bit because I have faith that the last lesson made complete sense to you. And if you didn't, maybe go over it again. Write down the notes. There is some stuff on your playlist that can supplement this. But we're going to jump into it because I don't want to waste too much of your time. So the next thing we want to talk about is finding arc lengths in radians. And this is where the bulk of the last half of the questions on the assessment will ask about. They'll give you degrees sometimes, but when the answers show up, they'll ask you for the answer in radians. So this is probably the most important part of this video. Okay? So just like we did in degrees, we're going to do the same thing-ish in finding the arc length. Okay? It's the same concept of taking the total and timesing it by a proportion in order to find the missing variable. Okay? Let's begin. I think it'll make more sense when we actually start. So the first thing is a little backtracking to a piece of information you need to know before we begin this. Is before, when we times it by a proportion, we chose 360 as the total degrees. Well, in radians, the rule is that 360 degrees in radians is equal to 2 pi. Okay, I'm going to box this because this is really important. That's all it really is. You just kind of have to memorize this. This 360 degrees is equal to 2 pi. Say it with me. 360 degrees is equal to 2 pi. 2 pi, 2 pi, 2 pi, 2 pi. Cool. And the next piece of information we need to know is going to be a formula that's going to help you throughout the whole playlist, okay? And it sets up a proportion for you to plug stuff in and find out the unknown. So the formula I'm going to give you right here is arc length over total circumference is equal to sector angle over total circle angle. Okay? This formula is going to be your best friend. All it does is set up the proportion just like we did before, except this one's just more set in stone for you. So if there's anything you should write down in watching this part of the video, it's this and this. Okay? So we're just going to take our information now and follow the steps and input what we do know and try to find out what arc length is. So we're going to denote this as x because this is what they're asking for. So the total circumference, what we have to do is we're just going to take this, okay? Remember, we're going to write down the formula for circumference, and it's going to be diameter times pi. I wrote that backwards, but it's the same thing. Diameter in this case is going to be C is equal to 7 times 2, so that's 14, and pi. Okay. When we do it in radians, we don't go any further than that. We keep it in terms of pi. Okay. So this right here, x over 14 pi. We set the first part of our proportions. Next, we're going to do sector angle, okay? And the sector angle given to us is 5 pi over 4. We actually just take that as is, cut it out wholesale, put it right over here, okay? So 5 pi over 4, okay? This is where it gets a little messy because we have a fraction over a fraction over total circle angle. And remember, we learned that the total in degrees is 360, when in radians, it's just 2 pi. So we're going to do 2 pi right here over 1. Or, you know what? I think it would make more sense to just say 2 pi. Okay? At this point, all we have to do is do algebra. So in order to get 2 pi out of the way, right, to get the denominator, we need to times it with 2 pi on top. 2 pi on top. So now we get 2 pi x over 14 pi is equal to 10 pi over, it's just equal, these crossed out, so it's just equal to 5 pi over 4. Okay, I had a brain fart right there. But look at right here, we have pi over pi. These just cancel out, and we can simplify this. Okay, 2 over 14 is equal to 1 over 7. So I'm just going to erase this because I'm running out of room. But it's going to be 1 over 7 x is equal to 5 pi over 4. Now to solve to get rid of x, or to isolate x, I beg your pardon, we're just going to get rid of this 7, multiply 7 over 1, 7 over 1, and so now you get 30 pi, or you get x is equal to 5 times 7, which is going to be, 35 pi over 4. And you can't simplify that any further. So your answer is going to be that this arc length is equal to 5 pi, 35 pi over 4. That's it. Follow these steps, write it down. It's all plugging in. The messy part is when you get to the algebra because you have fractions over a fraction. But I trust that you guys can get through it by yourself. Okay? Happy studies.